Hello friends, now welcome to the next video of isoparametric elements and the numerical integration. Into this video we need to do the study of shape functions and the area coordinates. As we know, the displacement functions are defined by the polynomial shape functions. Now what is that one? So you knows very well there are the certain terminology we use whenever we are defining the polynomial shape functions. So in a polynomial shape function, if there is only one term, then that is constant. As we know a Pascal triangle. So in a Pascal triangle, we understand how to define the polynomial function. So here there is a constant, that is 1x. Then here, if the problem is of the 2D, then here this one is the x and this one is the y. If here there is another term, then that is the x square. Here there is a y square, and here in between these two, and there is in between these two at the center there is another term, that is the 2xy. Or sometimes we observe xy. So this Pascal triangle we knows very well. So whenever we have taken the two nodes, okay, so each every node, if there is a 1 degree of freedom, 1 degree of freedom is only 1 degree of the freedom along x-axis. So how many terms are required to define this displacement function of a 1D problem? Then there are the two DOF. So if there are the two DOF but degree of the freedom is 1, so that how many terms should be there? So there are only the two terms are required. Only two terms are required. One is a constant term, plus a1x, a1x. So my displacement function u is equal to a1 plus a2x. Why there are the only two terms? Because there are the DOF, 2 degrees of the freedom. If there are the 3 degrees of the freedom, then there is a third term comes. So when there is a third term comes, then that equation is equal to that is a3x multiplied by x square, not x but the x square, because this is the constant term, this is the x, and this one is the x square. Because this is the 1D problem. The 1D, whenever we are considering the 1D problem, that time we have taken only one line of my Pascal triangle. So this is my process just to write my displacement function. So what we understand from this shape function, so if there is only one term, then that is called as the constant term. If there is a linear term, this is the linear term, then I need to write this one is the alpha 1 plus alpha 2x. If there is a quadratic term, then it one is reaches to my original level. This is my original line. So if I want to go closer to this one, then I need to use the quadratic term. So whenever I am writing the quadratic term, then I need to use the 3D parameter. Then my u is equal to alpha 1 plus alpha 2x plus alpha x3. So that it one is getting the one bending, and through that bending I am reaching to closer to my figure, because my original figure is this one. His original figure is this one. So here it one is match, here this one is match with my parameters, and this is called the quadratic equation. Now polynomial shape functions. So in a 1D problem, the polynomial shape functions are defining by this method. So whatever the terms are there, whatever the number of orders are available into this one, so that is equal to m is equal to n plus 1. So if the order of the complete polynomial is 3, so if there is a 3, then there are the four four terms are come into the picture. So whenever the problem of the 2D, then the formula, that is m is equal to n plus 1 into n plus 2 divided by 2, that is equal to 6 terms. So whenever I am writing my displacement function, u is equal to, if there is a linear term, then my n is equal to 2. Linear term n is equal to 1. So if I am writing here 1, n is equal to 2. Now see here, the n is equal to 2. So when my n is equal to 2, so what is that? N is equal to 2. Just let us move on this term. Now see, this is the constant term, this is the linear 3 terms, quadratic 6, cubic 10, and the quartic 15 terms. Approximately this much parameters come into the process. How to calculate? What is that formula? That is, if n is equal to 2, n is equal to 2, then n plus 1, n plus 2 divided by 2, so we are getting the 6. So there must be a 6th term. What is that? That u is equal to constant term, that is a1x, a1 plus second term is a2x, second term is a2x, third term is a3x cube, a3, sorry, this is the y, a3x, a3y, fourth term, that is plus a4, a4, that is x square, that is x square, then plus a5, a5 y square, a5 y square. So these are the 4 term and these are the 2 term. So total 6 terms we need to write just to define my equation as per the Pascal triangle. Now this one is the polynomial shape function. This we have already studied. Through this one, how many terms are we are getting? If there is a linear, then 1, if the degree of freedom is 1, if quadratic, then the 6, cubic 10, quadratic 15. So this is my formula for the 2D. Now this is the 3D. This is the formula: n plus 1, n plus 2, n plus 3 divided by 6. So that is equal to whatever the terms comes, then that is the formula for finding the number of terms. This is my Pascal triangle for 3D. Pascal triangle for 3D. So this is constant, this is linear. Again, when the object is three dimensions, then there are the terms. So one means u is equal to, when there is a linear term, then u is equal to a1 plus a2x plus a3y plus a4z, a4z. So if there is a linear term, then there are the around 4 terms is to be come out. If there is the quadratic terms are available, then around this term, so there is a more number of a term, around 10 number of a terms come in a picture. So this is the formulas and methods to use the Pascal triangle. Now let us move on the shape function into the natural coordinate system. So let us take, this is the good problem of a linear displacement model. So let us take, this is the problem, that is, this is the node number 1, this is the node number 2, and this is the node number 3. And on every node, these are the coordinates. These are the coordinates. What is that? 1 0 0 is a coordinate, 0 1 0 is a coordinate, and third coordinate is equal to 0 0 3. Hence, as we know, this one is the first of all writing the problem into a linear equation. So alpha 1 u is equal to alpha 1 L1 plus alpha 2 L2 plus alpha 3 L3. So convert this one. So my L1 L2 L3 is a common. So alpha 1 L2 into alpha 1 alpha 2 alpha 3 is equal to u1 u2 e3. Hence this is equal to now alpha, that alpha u1 u2 e3 is equal to alpha is here, and now we need to write this coordinates. What is this coordinates? L1 is equal to, this is the 1 0 0, so I am writing this is the 1 0 0. Now this is the 0 1 1 0 1 0, and third one is the 0 0. So the matrix U matrix, that is the displacement matrix, is equal to that is D matrix 1 0 0 0 1 0 0 0 1 multiplied by my alpha matrix. Now I can very easily solve this problem. My alpha matrix is equal to inverse of my D matrix multiplied by U matrix. So that by using a transpose method, cofactor method, for finding the inverse, by using a cofactor method to to find out the inverse of this one. So this inverse is find out by using the cofactor method. We are getting this value. We are getting this value. So that we are getting that is u is equal to L1 L2 L3 alpha 1 alpha 2 L3. So that is L1 L2 L3 multiplied by this matrix multiplied by u1 L2 L3. So this is equal to L1 L2 L3 is multiplied by u1. So this one is the my shape function N1 N2 N3 multiplied by this function. Hence and for this is for u. Now if this is the 2D problem, so this is my u direction, and this is my v direction. This is my direction v. So for v also, by using the same formula n1 n2 n3 multiplied by v1 v2 v3 maxes. Hence u into v matrix is equal to L1 L2 L3 0 0 0 divided by the another row, that is 0 0 0 L1 L2 L3 multiplied by delta matrix. This delta matrix we need to find. Hence in a 2D, again the different shapes. Till now we have studied the 1D, 2D, 3D, then the constant strain triangle we studied this one, then the linear strain triangle we studied this one, then the quadratic displacement this one, then the rectangular one, that is the Lagrangian rectangle. This is the Lagrangian rectangle form of the shape function. Then the serendipity triangles, this is the serendipity. So in a serendipity we are not increasing the elements, or we are not writing the nodes into this inner part, while in a Lagrangian we are using the inner nodes, this is the difference between the Lagrangian and the serendipity rectangles. Now the nodal displacement, temperature and the potentials, this is called as the continuity of a zeroth continuity of a problem, that is the C0 continuity. What is that? So whenever we have taken a single parameter, then that is the C0 continuity, while when we have taken the d by more power value, that is the d square upon dx square value, then that is called as the C1 continuity. So the slopes, not only the displacement but the higher order derivatives are considered as a first order continuity, that is called the C1 continuity. Then we are knowing a coordinate system. So there is a local coordinate system, global coordinate system, and the natural coordinate system. Here we can able to define that is the continuity, that is the C2 continuity. Here you can see that the power is increasing, hence that is the C2 continuity. Now the natural coordinate system. We know the natural coordinate system in a two-dimensional is designated by the psi eta process. So this is the rectangle, and if I want to define my natural coordinate system, then this is my xi dimension, and this is my eta dimension. So this is my eta dimension. So natural coordinates in a 2D is defining by a xi eta coordinates, Now this xi is equal to p minus c divided by x2 minus x1 upon 2, where p is the point of reference, where p is a point of reference, and the c is the center point of the parameter. So if this is the, now see, this is the two nodes are here, there. So c is at the center, and the p is a point of a reference, so this is p, this is my p, and this is my center point, c is equal to, that is x1 plus x2 divided by 2, while this is my xi, is equal to 0. At the center point my xi is equal to 0. and at the one end xi is equal to 1, and at the another end xi is equal to -1. So I am interested to find out the xi. Then this is the formula: p minus c divided by x2 minus x1 upon 2, that is equal to x minus xc, that is x is this one, this is the parameter of x, minus xc, this is my xc, this is my center point, divided by L by 2, divided by L by 2. So now let us take this one to solve this problem. So what is that? Xi is equal to p minus c x2 minus x1 upon 2, that is equal to xp is equal to x minus xc divided by L by 2. Now this L by 2, 2 by L into x minus xc, xc is equal to x2 minus x2 plus x1 divided by 2, hence 2 upon L, x minus, now this is the x2, this x is here, now x2 is here, minus x1 plus 2x2. Now this one is distributed into minus x1 plus 2x2. Why this one? Because this total term is my L, so this is converted into the L. Now see, this is converted into the L. So 2 upon L, x minus, this is the L, plus, now this term is same one, that is the 2x1 divided by 2, hence this is the 2 upon L, x minus x1 minus L2. Now this one, hence xi term is already there, this term, this is equal to xi, this is equal to xi. So xi is equal to, this term comes to here, okay, or this term comes to here, so xi multiplied by L by 2. So see here, that is L by 2 multiplied by xi is equal to x minus x1 minus L by 2. Now this term, if I transfer here, then this is equal to plus, this is equal to plus L by 2, plus L by 2, L by 2. So if I taken away a L by 2, then the term 1 minus 1 plus xi is equal to x minus x1. Hence at node 1, my x is equal to x1, my x is equal to x1, hence L by 2, 1 plus xi, that x is equal to x1, hence x is equal to x1, this is equal to 0, hence xi is equal to, just by manipulating the term, we get the xi is equal to -1. Now here at the node 2, x is equal to x2, so this is the term L by 2, 1 plus xi is equal to x2 minus x1, x2 minus x1 is equal to L, so this is the L, so L by 2, 1 plus xi is equal to L, hence 1 plus xi is equal to L by L into 2 divided by L, so these are cancelled, so this is 2. Now this xi minus, this 1 is here, 1 is transformed to here, so 2 minus 1, that is 1, hence xi is equal to 1. So if I draw this line, and there are the two nodes, so if this is xi, this xi is equal to -1, and this xi is equal to plus 1, this one is derived by from this derivation. So I hope through this one we can understand how to convert the coordinate system into the natural coordinate system. Thank you to all.